Howdy do. How doody. Welcome to Design Study. Design Study #8. Howdy do. So we've got audio. Howdy. Welcome to. We've got audio. Lower the rest. Right. Okay, Design Study #8. Failure? ? Yes, no. Well, let's have a look at the model. Right, let's have a look at the model. Hello. So we're back on again. Made it. Oh, you can't see the nuts and bolts on that drawing. Right, let's bring it up. Physical thing. Let's just get rid of that. And physical thing. Let's switch over to the camera. Is that a good view, or have we gone a bit wild? That's better. Got some cables here. In fact, the cables are in the way. Let's try and get rid of them. That's not working. Hold on a second. Let's get rid of some cables. I'll tell you the easiest way is just to unplug them. Let's unplug them. Oh. Apart from that one, because that one's a bit stiff to get out. God, these coily cables are so springy. Oh dear. Get in there. I need some way of... That's it. Alright, that's better. Right, so what have we got here? We've made this. The model on the screen. Hang on, let's get the model on the screen. Here we go. So anyway, let's just bring that up. Let's put the bolts back in. Didn't realise I left the bolts out on the drawing, but anyway. Right, let's here we go. A lot of bolts on the drawing. This is a mad stream tonight. Anyway, this is where we got onto the last stream. So I had to redesign this on the fly, and due to the material thickness I had a certain material thickness. So anyway, I built it, we CNC'd it out, and in physical form, the physical size of it is a lot different to what you'd expect from a model. It looks the same. It's supposed to be a ghost. Supposed to be a ghost. Right, anyway. Now, this is normally, if you do a design, you do 2 or 3 designs and choose the best of the 3. Well, we did one. We modified it. Now, we got some certain design constraints. So we wanted certain space in between the bands wiring. I'll just get that better, yeah. Certain spacing. So we got 34mm, 68mm, 68mm. So 34mm, 34mm, 34mm. Now 34mm might have been a bit close together, maybe. So I allowed for 68mm. So you could get 1, 2, 3, 4, 5, 6 bands on this. And you've got area for a coil choke, 10 turns of a coil choke. If you're not sure what that is, have a look at one of the other videos. But anyway, and you've got cable tie for the coax, 2 studs, as per the drawing. Anyway, this was supposed to be, you hang it up like that, or you clip it onto a post like that, cable tie it, put a rope round, whatever you got to do to hold it onto the post. It's got a circle so it could sway that way. if you've got to hang it in trees and then you need it to give a bit. So basically, you put your wire down here for your one element, and you keep on going. Right. So anyway, the physical thing doesn't look too bad, but trust me, look how big it is. Look how big it is. I can't tell. How can I tell? How can I? Right. Surface Pro tablet. So it's twice the size of a tablet. It looks about the same as a tablet. So it's like two tablets. In fact, let's put two tablets together. If I could do it. Two tablets. If I can do it without dropping them. There you go. Look. There you go. Two tablets. So basically, it's a big thing, but when it's attached, the spacing of the wires would be right. Give you 6 bands. Okay. Now the idea was to hold everything still, and then I milled out these bits here. These bits that you can imagine, that was going to be literally going to be the holders for the cable. Anyway, we made one. Let's put that somewhere. Put that somewhere. Leave that there for now. Let's go on to this one. Right. So, anyway, that was the Ghost Design 1. And I went so far to build it. Let's get back to the screen capture. Right. Here it is, and it's SketchUp model. So you got a SketchUp model and milled it out. And what I didn't do, I didn't mill these out yet, but these stays, I thought they were going to be small, and I didn't realise that they were going to be quite big. So I underestimated the design. I allowed enough to do I think 12 bands, was it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you could do 11 bands. So anyway, so what do we do? So let's study. We've got to do a study. So go back to the thumbnail. Right, design study. Failure, yes, no. I don't know. It's definitely different. It's definitely different. Failure, I don't know. Until I built one. Do I want to build one from that? I'm not so sure. So what we're going to do is we're going to have a look at the concept of a fan dipole. What we'll do, let's have a look. We'll open up a... We're going to have a live... We're going to have a look at HF multi-band fan dipole. Let's see what comes up. Right, we'll go on images. Right, that looks... Oh, that's not good, is it? You're not even seeing it. Let's get over to that. Right, so I've just done a scan on Google HF multiband fan dipole. Let's have a quick look at this one. How are they done? They've gone straight off a balun. So what was I saying on it? So they've gone straight off a balun. Similar kind of thing. Straight off a balun. So the balun, now it's not fanning out well here. It's going up. I suppose it just depends. Yeah. So that's how we hold it, and then the rest is hung off it. It doesn't tell you how it's held together. A vertical fan dipole. Right, there's all sorts. Anyway, let's get back to the other pictures. See what other designs we got. So, just got a bit of plastic there. That's a bit of plastic with just wires off it. Fair enough. Right, I won't look at that one. Right, so we've got this type. That's another balun or unun, 1-to-1 balun probably. It's got 3 bands on it, look according to that. Are they using that as a dipole? No, it's a dipole. Right, so that's one design, and we've got another one here. What on earth is that? That's just a feed, coax feed. Yeah, really. I wouldn't say Heath Robinson. It doesn't look. Let's have a look at this one. Right, so we've got the actual wavelengths there written on it, and they're fanning out on it. Right, okay. So there's some confusion with these things. There's another example of one. Got some eyelets on a round. Oh, they've even got a coil. So even got a 10-turn choke on it. So yeah, that's a good idea. I'm not sure that's 6-inch diameter though. It doesn't look it, but it could be. Yeah, so they've done 1, 2, 3, 4, 5 band on a tube with eyelets. So yeah, that would probably work. That looks like a conduit fitting, doesn't it? So they've gone around there. I can't see the whole thing. I wonder if there's a web page for it. Consent. No consent. That's where they lose me. Right, anyway. So there's that style. That's it again there. Fan dipole. Someone's gone into a bit more detail there. They got insulators. Right, so what are they doing here with these insulators? Multi-band dipole compared. Right. So what are they doing here? They've jumper closed, outer open. So they're jumping past the things. Right, so yeah, okay. What's it got here? Oh, that's one of those. By the looks of it, they actually spread it apart. The further out it gets, well, it's just some fans out. Yeah. Let's have a look at this one. Nylon rope, 4 elements, pulley on each side. So pulley, standard sort of stuff, isn't it? Right, what else? What we got here? 10 meters. Yeah. What we need to do? We need to come up with an ingenious plan somehow. What's this one? It's just measurements. So you've got 1, 2, 3, 4, 5 band. 5 band. Oh, it actually gives you the meters. Antenna construction. Is spacing of fan dipoles necessary? They asked the question. I'd say so. Maybe. Right, anyway, so we've got various ones. What's this one? That's just sort of floating in the wind, isn't it? Oh no, sort of. Yeah, it looks a bit unsightly. So we're getting nowhere fast with this one. Nowhere fast. Let's have a look. Oh, this one looks a bit weird. Dipoles. Lots going on there, very confusing. What's this one? Bit like a pyramid. Nylon support. Screw-in base of metal support. Nylon. 40 meters, 30, 20. So they're sort of, yeah. So if they've tuned in for 30 meters or 20, do these ones behind act as reflectors? So if you tune in for 30 meters, would that be a director, and would this be a reflector?
That's about right. That's just local, but you know
Or
what I
they
mean?
just mean nothing to do with it. Parasitic something or other. Anyway. Alright, what have we got? What else we got? There's drawing or something. Alright, so we need to look at the design again. We need to make sure we can build something. Yes, we built it. Alright, let's go on the drawing. Let's go on the, go on this one. Let's decide what it is we don't like about it. What don't I like about it? Let's get onto the screen. Right, what don't I like about it? Well, it's bigger than what I imagined it to be. Actually, I'm looking over there to see what I'm doing. But anyway, it's bigger than what I imagined it to be. And it's a bit unwieldy. Maybe you could take the choke off. You could lose the choke, but you still end up with that big. So, but there'd be space to part nicely. But then when you stitch the cables up, it'll look weird. And the cables would come through there. So, and I can't fit this in my laser. I've CNC'd this out. I could just about fit this in lengthwise. Widthwise I can go wider, but then I didn't have the material thickness. What else? I don't know. If it was made of polycarbonate, it's probably going to be a dear bit of plastic. Might not be necessary. So, let's have a think. So the idea of wrapping the choke around on that one we saw on the screen. Let's go back to it. Where did we see it? Let's get that one up. Right. So the idea of this one here, a piece of pipe, they drill through, piece of all thread in the middle, screw your eyes over, coil your choke around the tube like that one, coil it around. I don't know, they're holding it on, they just glue it on or cable to wrap it tightly. So they're using some kind of, that looks like a cap there, doesn't it? Yeah, so they've used capping and a tube. So probably DIY stuff you could get hold of. Not sure what that is there. Strain relief. Oh, that's the strain. Take the strain of the wire, and that's the electrical conductor to the part of where the balun is. I don't know. Might not be a balun. It might just be the coax and the feed line. It looks like a balun, unless they've made a balun and put it inside. Could have done. Capped it off. There's a lot of there's a lot of building on that one. Drilling and building. This thing is crazy. This thing is. It's big. It turned out bigger. That's the size of a tablet. Look at the size of a Surface Pro against it. It's twice the size. Yeah, I could build it. Should I build it, or should I try and come up with a different design? You've got the spacing between each band, 68mm, 68mm, 34 between the twos there, and I've got to make a load of these as the stays. So anyway, back to the model. So let's go back to the model. Here we go. So I've created the model, and I had to modify it last minute to make it fit the material, the width. So model 1, I'm not sure. Anyway, I like the idea, but I've got to mill out these, and these are quite long. They look small on the drawing, so they're the same length as that without the coil. So I went to the clip idea to old and taut. I haven't built it, so we milled out the plastic. Actually, you can't see me, can you? Hang on. That's it. So we milled out the plastic. Got the plastic milled out. And it looks unwieldy. It might turn out okay, I don't know. I suppose I could build it. There's a lot of milling to do. And it won't actually, the design won't fit into my laser. It'll fit into the milling machine, but not the laser. And I don't want to. Hang on, let's get back onto this one again. Take some. When you mill it, you have it with a few rough edges like that. You can just about see it. You see the rough edges there. I need to take the edges off, but I don't want to play around too much. Spend time on it like that, filing it and that. I don't want to be doing that. So it needs to go into the laser, so it just be automatically smooth, nothing to change. So I mean, it might make a good aerial. I don't know. It might have made a good aerial, a good dipole. I don't know. Well, that was the first design I came up with. I'd have to coil the coax around here. So get some coax and feed it in around 10 times. Bring the feed line up to here. Put the bolts in. Strip it. Cable tie it on. I suppose I should make it really. Should make it up. Might still make it up because you need to know what the tuning's like on it and stuff. Alright, let's get back to the model. So anyway, traditionally you wouldn't go with the first design, you'd look at 3 designs and then you'd sort of try to find out which one is the best one. But just looking at a design in a model is not enough to. It's not enough, right? Basically, it's not enough to just look at the design. So I need to redesign it, I think. And this is not the aerial part. This is just a holder. So it'd be nice if that could be some kind of reflector. So we've got the bands, the low, the longer wavelength at the top. So it's a bit. If we had the longer ones at the bottom, and then the shorter ones as they go up, this could then be a reflector, but it'd be directional upwards. Or you could lie it on its side. Instead of having this vertical, you could have it on its side, probably with a hole in the centre, and it'll be directional. You'd have to turn the whole thing. Basically, you'd spin the whole thing. If you had the design, like this, so imagine if let's hide the base. If I give the base, let's make the base a base layer. Let's put this. Let's hide the base on a layer. Let's get rid of the base. Alright, we've got the feet there. Alright, let's get rid of the base and poles. So we'll call these poles the base. So let's get rid of the feet. Base, and let's get rid of these a minute. Fill in the base. Right. So we'll get rid of the choke. Coax feed. Feed line. Oh, it's only getting rid of that. Let's make all this part of the feed line. So we'll get rid of that, that and that. Put it in as a feed line. Let's get rid of the feed line. Okay, so we just got
I'll have to get it round here.
Leave them there. So let's get rid of that. Let's make this part of the let's make this part of the
3 watts, I think it gives about 40
part of the base. We don't want to see that really when we want to hide it away. So let's get rid of that.
They'll use it, so you're welcome to it. It's a dual band one.
Alright, let's make that part of the base. That's gone out the way, isn't it? Right, so what we got left? Oh, we didn't do that one, did we? What's happened to that one? Must have let go of it.
Yeah, you should be able to then. Hold on.
Right. Let's make that part of the base. Yeah. So all we got is the plastic left. Got the plastic left and the studs, the bolts. We can leave them there for a bit. Right. So.
Oh, Steve. Oh yeah.
If it was sideways on, look, these would sag, don't they? They'd bend like that.
4-7 or something. You're
You're gonna have your long wire, your long stay cable across the top for stability, and then these hang off it. So I don't know. Yeah, it's a weird one.
But when he comes on, sometimes we get that you snapped it up with his radio warms up.
So let's just put the bands on. So have I got elements? Elements, right? Okay. Let's switch off elements. Right, let's get the elements on there. Let's just put the elements. Oops. What's that? Have I gone into?
Don't really give me much indicator. Actually, it's just a light that's flashing.
No.
But if Bill reckons you.
Right. Oh, because that's behind. That's why I couldn't select that. Right. So I just want to get rid of these elements a minute. Oops. Done it again. Let's get rid of these elements. So what I need is some ideas, basically. Some ideas.
Flashing like crazy, Malcolm.
Yeah,
I can make it, but unless I go ahead and make one. Go ahead and oops, not that one. That one. Alright, turn it round. Let's get the back of these. Just gotta make it so I can turn these off. Oops. Oh, that's not going, is it? Oh, that one. Have I put them on the wrong
So
side?
he's going over to another radio, apparently.
Right, let's have a look. Let's put them onto the elements. Elements. Turn off the elements. Right, we've still got some more left. That must be on the other side. I must have gone on the wrong side. Yeah. That one isn't. No, there's that
That was
one.
you, Steve. You stopping, but no audio.
Elements. So what we got left? Oh, there are the wires around the other side. Some of them. Right, I was just trying to.
47, he's a lot better, Steve was there. Where's that at? Where's that to?
Why have I got two colours the same there? Oh, right. So elements. Right, is that? I don't know where these are. So I can get that, and that. Put them in as elements, so they've all gone, yeah. Gone out the way. Right, let's have a look. They've all gone out the way. Right.
Switched it over to another radio, didn't he? He did that.
Let's have a look. We can get rid of the bolts, can't we? Bolts.
Yeah, go on, Steve.
Element rings.
Have you got
Yeah.
him, Paul, Bill?
So I've just got the thing. What about clips? R clips. Can we get rid of R clips? Let's have a look. Right. So let's make a new one called R clips. Right, let's select all these R clips. Right, let's see these R clips. Right, they're all R clips. And turn off the R clips. Right. So I've just got the other R clips. Let's just get rid of them as well. R clips. And let's just get rid of. Make another one. Call it. They're not the elements. They're the catenary.
475.
Catenary
If you're
wires.
on 550, you've got to go to 550.
Excuse me. Right, let's get rid of the catenary wires. Right, catenary wires. Okay, let's get rid of catenary wires. Now, elements.
Then he comes back on frequency, doesn't he, Paul?
I seem to have lost an element. Ah, where's that gone? R clips, that's not an R clip. That's a catenary wire. Okay. So turn off the R clips. Turn off the elements. Right, so we've just got left now. Just got left these, so let's the stays. We've got stays. Right, let's create a new one called stays. Okay, let's put all these in the stays. All in the stays. Turn off the stays. So we've got wires Right, so we need to get rid of that one.
Boy.
Okay. So if we turn them all on, so we've got the base. Yeah. Okay. So we've got just this now. This please.
I'll just tweak the volume up slightly.
Yeah. It's a bad design from Al. Definitely a bad design from Al. Anyway, let's bring up that design and have a quick look at it. Let's put everything back on. Make sure it's all there still. Yeah.
£150.
So we've got to redesign it. So how do we redesign it? Let's have a think. So what about if we made it out of a tube?
You're not getting it, mate.
Make it out of a tube. Well, the idea was it was to be simple. Simple and easy to build. So you can build it all up in your...
Yeah, whoever give it outside.
Yes, you build it all up and sew it all together. Embroider it. Okay, so you embroider it.
Did I call it back out? Don't worry in the budget. Have you seen the latest plan, mate? You know all these pubs.
So you embroider it while you're in your nice warm house or building. And you take it out and just mount the posts this side, that side, and mount this onto there, and away you go. Alright.
And beyond. It's 8:30 p.m.
So
So at the end of the day, with a few inches, well,
take a bit to wind that round. You'd have to feed it through, then round up here, and then make the end off. So you could do it. I've got a bit of coax, so I could start doing it and cable tie it on. So you could build it. And then we've got 1, 2, 3, 4, 5, 6, 12 of these to make. And it depends whether they sag enough. You might need more. But these will be quite heavy. They're quite heavy. Right, let's have a look at some more designs, I think. More designs. See what's someone's made their own fan dipole bits. Alright, let's carry on with some more design. Try to find something design wise. What we got here? We've got a bit of a, what is that? Looks like it's got a fishing thing.
It's getting ridiculous, isn't it, eh?
You actually use speaker wire there. Actually listen to, you know, what I got here. What's this? What is that? Oh, way of joining two together with a strain relief. I got you.
You see about, you know, having a swag outside.
Okay.
And that, but if they stop.
We've got this one. All strain relief onto a 1-to-1 balun. So that looks okay. So what is wrong with that idea? Is there anything wrong with that idea?
Right there. I was just telling Paul. Oh, by the way, Paul.
Probably not.
I spoke to you.
Nothing wrong with that idea.
The doctor wanted to go back, and the doctor wanted to find the ambulance. Take him to the hospital.
V, yeah, if we got less space. Alright, what we got here? 1 to 6 balun. Okay, so the offset feed. Offset fed fan dipole. Oh, that actually goes back and forth on the same element on this one. So it's a dipole, but it's not a fan dipole.
I had to go again today, our mechanic, for a deep X-ray or whatever.
It's shortening the length. I got you. Right. Okay. What else we got?
It's a bit daft, there you go, really.
What's this one doing? This is the same idea, I
We're
think.
all the same.
Yeah, so they're using a fan dipole as a single band just to shorten it.
I gotta go. I don't know if I'll be back, but I might be. I've gotta move.
Small plexiglass plate, cut and drilled. 450 ohm ladder line, right, okay.
Yeah, okay, mate.
Don't think we're quite ready for ladder line yet. See if there's anyone on sideband. See if we got any on sideband. What about 10 metres?
Yeah, well, all I can do now, but you went. This is it now, come on, he's been on half a dozen, eh? This
Right, there's nothing much on there. That looks a bit dead. Okay, we'll leave that one then. Right, so just having a look at some designs for fan dipole at the minute. What they got here? Dipole ABC, all from one centre fed, then they're hung off somewhere else. Alright, that's a different one, isn't it? What's that one? Made out of plastic waste pipe, maybe? Conduit? Taped, just taped in position, maybe. Oh, they've got a balance hung in the middle. So they're using the piping as a frame, really. Similar idea to the similar to the plastic. Similar to that. The waste pipe is holding it all still, but then the waste pipe idea. So the waste pipe idea, you'd have to get the waste pipe, and then you'd somehow have to fasten each one of these. So yeah, so you'd have to tape it on or something. Right, okay, that's one idea. What's this one? Somebody's done 10, 17. Right, so there's 1, 2, they've got 6 band. They've coiled it all up. Half wave fan dipole. Right, okay. So they've done it all in grey. The loops on. Ready to go. And the problem is they look a bit weird, don't they, when they're all spread out. This one, single band by the look of it. Dick's Engineering. What they got down here? Antenna wire, single band, ladder line. So yeah, if you want to do single band with a ladder line, yeah. What's this one? Band hopper 5 or whatever that is for. Show for illustration. A band hopper. So Right, so you got closed. Your antenna may cover different bands, but the principle is the same. Open means the crock clip hangs down. Right, so that basically undo a crock manually. That's not good. Not good if you, unless you want to go out in the cold every time you want to change. Right, don't like the idea of that. Right, what we got here? No. Let's see what else we got. Somebody's got a load of loops here. What they got? Oh, join them all up. Separate lines. Quite a small, compact thing. 3-band. It's 160, 80 and 40. Right. Okie dokie. What else we got? Any more ideas? What's this one? Don't know what that's going on there. What else we got? Oh, this is an interesting one. Let's have a look. What's this one? Electronic warfare, jamming and surveillance. Oh my god. Right. So that's like your driven element, and you got your dipole off it by the looks of it. Is there a bigger picture? No, I won't be accepting that. Right, so there's another version of it there. Right, so it's directional. It's a directional thing. It's like a Yagi, and it's got beams. Don't know which is the driven element now. Are they all driven? No. No, that's actually connected all the way through. Oh, they've got some little ties. Oh, I don't know. Don't know that one. Can't see that one. Anyway, never mind. Looked interesting. Right, got another one here. Looks interesting. Looks like tent pegs. Right, what else we got? What's this one? No. This one. Typical dipole antenna. FC dipole prevents an RF coax braid, prevents dipole from becoming a tripole. Right, whatever. Okay, and you got this weird looking one here with the bits of plastic. This open wire line spacer. Right. Thin bit of plastic, and I suppose you've got to keep it taut. Keep it taut. What else we got? What's this one? 2-fold HF broadband antenna. Okay, so they've joined it in the middle. Looks like a balun or something, doesn't it? They're quite big things, these fan dipoles, in reality. When you look at them, you think, oh, they're only small, but yeah, they're quite big. So I suppose we could make a third design. I like the idea of a circle, me. Right, I like the idea of a circle. Let's go back to the design then. Let's see if we can't develop something with a circle. So we've got this one. Let's start with a circle. Right, so what we'll do is we'll save that one as it is. And we'll save it as number 2, design 2. So save as. I got fan dipole, design 2. Right, so we're going to design 2. So what we're going to do? We're going to get rid of this. Yeah, we're going to get rid of this middle piece.
This is Mike 0 Charlie Uniform Sierra. Mike 0 Charlie Uniform Sierra. Listening for any calls.
So let's get rid of everything. Listen for any calls. Right, let's get rid of everything apart from the the ghost. Right. Okay, so this one I'll use as a template. So we want to make it smaller and make it into a disc, maybe.
Mike 0, Charlie Uniform Sierra, Golf 0 Uniform Foxtrot Echo. Are you still there?
Make it into a disc. So let's start with a disc. Let's just put a disc out here. Let's say it's going to be no bigger than that, so 200 mil. So let's say 100 mil. 100 mil disc. Right.
CQ2, Mike 0, Charlie Uniform Sierra.
We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Golf 0, Uniform Fox Echo.
So we'll undo that.
5 stations call me then.
We're going to do 5 bands.
Up to 525.
We'll make it 5 bands. So we're going
I'll put a call out again. I'll
put a polygon
I'm going to QS 525.
or a circle.
To see whoever I can hear.
Well, let's make a polygon. And let's say it's got 5 sides, so 10 sides. And let's make it 100 millimeter. Right, so let's see how many corners we got. Or faces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 faces, 5 bands. So we got, yeah. Now the only problem is it will, yeah, so we need a couple more faces. Yeah, so we need a couple more faces. So we can do, if we do them from point, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we could do it that way. At least the centre feed would be sort of equal length around it, but then you got to work your separate sizes out. So what would be nice if you attach the cable. And they're on springs that retract them, bit like a dog's lead. So you have a carabiner or a hoop, and you pull it out of there. You attach it to something, and you clip them on, and you can unclip them as well. This will wind it back up, but then how would you wind it? Tapes. I saw Waters and Stanton, the old man there, who's using tape measure the other day on as a ground plane. Yeah, the trouble is when you look at weird, wouldn't it? Tape measures coming out, 5 tape measures, but they would retract themselves, and then normally about 5 or 8 meters long. Right. So let's got to think out the box somehow here. Think out the box. So we had a disc. It's just a means of holding it still, and we already had this idea anyway. How about we do a different one, a horizontal one? A horizontal one, fan dipole. That might be better. And basically, they all fan out at the same height horizontally, away in different points around the garden. And yeah, I like the idea of that. So let's start again. Let's undo that. Let's draw one on the floor. Well, let me draw one on the floor with it. Well, if I do that, Right, so let's do 100mm. Right, let's get rid of this one a minute, the ghost. Let's make a new one, call it disk. Don't know what else to call it. Let's put that into the disk. Make a component. We'll put it under disk. Okay, so we're going to create a disk. Right, so we've got our disk. We've got our 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so we need to find opposites. So 5 band. Yeah, that's good. Okay. So right, we've got our disc there. Each part. Let's measure it across. So it should have 200mm. Yeah. Sounds good so far. Let's come in enough on the disc. So we need to come in from different angles, say 15mm, 15mm from all angles, 15mm from all angles. 15mm from all angles. Almost there. 15mm from all angles. So I'm doing design 2 and I'm going to make a horizontal fan dipole that when you look at it from the ground, edge on, you can only see one wire. It doesn't go all over the garden, it goes to your fence line or wherever you want to put it to. But each side of these corners is going to be, oh, we're missing one there. Each side is going to be 15mm. So we need some holes in it. Need to know where we're going to put our holes. So is that's just over 15, isn't it? Right, hang on. What we should have done is done them that way, shouldn't we? Right. Okay, let's undo all that. Undo, can I? Backspace. Control and backspace. Right. So what we're going to do is 15mm. Can we do that? Yeah. So we just want to do this. Carve it up. That's it. We want to come in 15mm. And there, all the way around, 15mm. So a disc edge on, so you can't see it from the floor. From above you can see it. From the floor, in your garden, you can't see it. And the wires, it's basically like a ground plane. An elevated ground plane, but it's not a ground plane, it's your dipole. Right, let's put some holes in for the fixings. They're 6mm. Let's put them in. Keep doing it. Right. Let's get these fixings. Okay, so we've got our fixings. Save it. Right, so we've got our fixings. We're going to have our feed line coming into the middle. So we've got to choose 2 points here where to feed it from. We could put could put an SO239 in there somewhere. We'll work that feed out later on though. Right, let's take these off. These marker lines off. Got our holes for our mountains. It's 200mm diameter this thing is. Okay, so we've got that. I suppose we better have a hole in the middle. That's about that. Right, so what size are we going to make that hole? Doesn't matter. Let's just make it. Let's make it 10mm. 10mm hole. Right, so we've got our plate. It doesn't matter which way you run it. You can wire it anywhere if you want. Let's just make it into something. Let's cut them. Put it, paste it in place. Can't do anything with it. Let's make it the right thickness. 5mm thick. Okay, 5mm thick. Right, we've got that. That's alright, apart from that hole isn't ready there. Why have we got no hole? Now we have. Oops, don't do with that. I can put our bolts through it. Our fittings, we can reuse some of that stuff we've already designed. Okay. So we've got our plate. It's going to sit horizontal like that. And you're going to run your cables out opposites. So your 20 meter band dipole that way, one this way, and so on and so forth. So you're spreading it round. It is really looking like a fan dipole. It's a weird one though, very weird one. Right, so we can do that. We can do our feed line. What about our RF choke? So you're not going to get your RF choke. You could do it. You could just wrap it round there. So your choke could fit underneath. You could cable top, put some holes round, tie it, just spin it round underneath. Maybe. Right, let's save that. Save. Let's go and bring an RF choke in. Let's get an RF choke off the other drawing. Alright, copy, back we go. Do you want to revert back to the same? What? No. Oh, what's it doing? Do you want to save? No. Right, so okay, I don't know what he's asking then. Right, so we're going to paste in place. Let's have a look. Where's it put it? It's not put it anywhere. Why hasn't it put it anywhere? Paste. It's not done it. Okay, go back again. Save changes. No. What's it done with my fan die? What's it done with my coil? Choke. It's under a layer of choke. I haven't got the layer of it. So I have to cut, copy. Go back to there. Alright, let's try again. I haven't got a layer called choke, have I? Oh, I have got a layer called choke. Wasn't being displayed, hang on. Paste in place. Where are you? There you are. What are you doing over there? Oh, I've got another one. I've got loads of them. So it probably did work, just didn't have the layer on. Right. Right, let's get down here. Come on. Go on down there, you bugger. Right, let's get down there. Come on, get over there. Why won't you go over? Oh, God. Right. Okay. Right. That's quite wide, isn't it? 6. What's the width of that? 160 mil. So that's quite wide. So 6-inch former, 10 turns. That's all of its money, isn't it? Really, that's all of its. Right. Let's grab hold of this. Let's get this from there and put it in the middle. There, like that. And drop it down a touch. Drop it down 5 mil should do it. 5 mil. Right, there we go. So, yeah, you could have a bit of a former. Okay, so the holes are in the way, but yeah. Holes are in the way. Dear me. What are these designs, right? What do they like? Yeah, so anyway, I mean, I've made that separate on my one. I've just made it a separate thing and sat it somewhere else. It doesn't have to be right close to it. So, but I want it to be in one, don't you? Maybe in one. Anyway, we'll put the check there. We'll just disappear it for a bit. We'll look at the rest of it. So, how do you mount this? Actually, you could just make it float. So your wires would detach and they'd be its own catenary. That it would float, or you could put an eyelet on it and attach it up onto a pole. What about if you wanted to make it float though? Float with your wires. So you're going to have 5 bands coming off it, so 10 wires. It's only lightweight. The bolts are probably way more weight than the thing. So 10 bolts. 10 bolts. Is there another way of doing it? So what will it look like? So what we need to do is see what it's going to look like. So we could do with some fence panels and stuff. Build a house. Tell you what, shall we get a house in? No, not yet. Right, so what we want to do is put some wires off it. Different lengths. We want to get a feel for what it looks like. So we're going to put some sizes in. I forget the sizes now. Well, let's just put some random sizes in, rough sizes. So whatever the band is, will go half the size. So what we'll do is we'll put a wire in. We'll go from here like that. And we'll go in line with this. Hang on. So we'll go to there. And we'll say this one's going to be 20 meters. Oh, that wasn't quite right. Wasn't 20 meters. We're going to say it's going to go 20 meters, so it's 2000. Right, let's have a look at that. Where did it go to? Let's measure the length of it. $20,000. Yeah, that's 20 meters, isn't it? 20,000. 10 meters. Oh, 20. Oh, I don't know. I'm no good at maths. 20,000. 20 meters. Oh shit! I wish I was any good at maths, you know. Right. Anyway, I'm useless at maths. I'll admit that. I don't know why. Why am I useless at maths? Anyway, so that's 1 meter times 20 equals 20,000, just like I thought. Okay. Maybe I'm okay at maths after all. Just don't understand it. So we're going to have one that way. Oh, we need some studs. Can't go to the centre like that. So we're going to need some studs. Let's make some studs. Let's get rid of that a minute. Right, so where are we going to put our two feeds? We're going to go like that, and we're going to go this way 15 mil, and this way 15 mil. And we're going to put our 10 mil, not 10 mil, sorry, 6 mil. Two 6 mil R's. And we're going to put our, go away, paint box. Right, then we're going to go, let's get rid of that and that, cut them, put it into there, paste it in place, and just put our holes in for our studs. Okay, so we've got our stud holes. Now the problem is they're going to go weird. Right, they are going to go weird because that's not the middle now. Does it matter? So it attaches to there, and then you have a tail coming off to there. Yeah, because that'll be that side, and this will be this side. That's fair enough. So let's put our bolts in. Do I want to do all this? I just want to see what it looks like. Right, let's put our wires in. So the first one we'll do, the longest wire will go 2000 that way. And we'll do another one here. 2000 that way. Right, so we've got our, oh god, looks big. Yeah, we've got our 20 meter section. What should we do next? So we're going to, how are we going to go? What's the next one? I don't suppose it matters. So what's after 20 meters? 17 meters. We're only having 5 bands, aren't we? So 20 meters, so that's your 40 meter. Then we want 20 meters, 40, yeah, 20 meters. Let's do the next one. And this one we want to do as Oh, done that wrong, haven't I? Done that wrong. So we want to go from there. We want to go 20 meters that way. Yeah, 20 meters that way. And 20 meters that way. Then we want to go, we'll make the next one. Doesn't matter really, let's just go on this next one. And we're going to do 10 meters that way. And the next one will be 10 meters that way. Right, and then we want to do, that will be the 20 meter band, 15 meters. Let's do the 15. 17 is one of them, isn't it? Can't remember now, let's have a look. 17. Let's have a look. Oh, 18. Oh, it's in megahertz. That's not good, is it? Okay. Well, we can alter them after anyway. So say 15 meter band next. So 15 meters is 10 meters. 7500. No, I've done too many there. 750. Oh, 7, yeah. That's it. I think. Let's have a look. Yeah, it's looking right. Same this way. Just need to get a feel for what it looks like. 750. Okay. Right, what's next? Next one will be that's 15 meters. 40, 20, 15, 10 meters next. 10 meters. So this will be 5,000. Another one over here. 5,000. Okay, we've got one left. So it's going to be 6 meters. Let's do 6 meters. Okay, 6 meters. That's going to be 3,000 that way. Oops, wrong thing. Getting a feel for what it's going to look like. Okay, let's have a look. So we've got, let's give it a save. So we've got weird looking thing, different sizes on it. Can't really tell a lot from that. I'll leave it on the screen. I'm going to go mute for a second. I'll be back in a minute. Back again. Back again after that. Medication time. Medication time. Okay. Right, so where did we get to? Let's have a look. So we got this weird concoction here. So does it even need to be that big? If you're not having the choke, then probably not. So what could you do instead? Do you know something? It's starting to look like a cobweb antenna, isn't it? Maybe you should just go for the cobweb antenna. Because the trouble is the elements are too long. Look how long the 40 metres is, 20 metres either side. Nobody's got 20 metres. So looks like they do an L cobweb antenna. They turn a sharp L and then they go a sharp L and sharp L. They go round. And it's a dipole nonetheless, but it's a fan. It fans out. I think we should just, this idea, there's nowhere to put these elements. If the band was higher, so you could get, you know, if they were higher up the band, but it's HF we're talking about, so maybe she'll go to cobweb antenna. It's still a dipole, isn't it? It's still a dipole, but not as you know it. Right, okay, I'm liking the idea of that then. So then these no longer become the elements, they become the wires that hold it still. So what about if you could use them, you don't use them as radials. How do they do that on a cobweb antenna? Oh, you don't need a radial because the one, that's right, the one is the radial and the other one's the element. So it's just a matter of bending it, or you can start from a point of view, go around it, and as it spans out, you get the longer length. Say 40 meters. You'd have to go around, wouldn't you? You'd bend at those joints and then follow it round till you get back to the start. But you'd have to start. They normally go up, don't they? That's why they go up, I think. So they go vertically up, and then they attach at different levels as it's bent round like that. But why not? Why can't you do it flat? Why can you not do it flat and just connect this to your fence line as high as your fence, and you just connect your wires, but then you've got to go across. So it is exactly like a cobweb, a bit like a cobweb. So you need to keep some way of keeping the wire that you run up here. We'd have to bend at a certain, no. Well, these would join it to the fence line round your garden, and then you'd have to fasten your elements between these points. So you need a way of Actually, yeah, you could do it easy, very easy. So what you do is you build yourself something like this. Let's build something, right? Let's start life. Let's do. Right, let's say it's let's just say it's 30 mil, so 15 diameter. Right, and we go. Yeah, we go across. So we'd have a, yeah. So 15 diameter, let's put another one in. Go from there, 30. Put another 15 diameter, well, 30 diameter. 15 radius, like that, and another one. Another one at 30. Ah, don't want a line, don't want a line. We want one of the, oh, what's happened? Redo circle. Measure from there to 30. Put another circle. 15, so we've got them. And we want to join up. Just join them up like that. Too much, maybe like that, or like that. What about like that? Maybe. Okay, what's that look like? Sort of. Right, let's get rid of the lines. Let's get rid of these. Okay, let's just grab that. Make it a component. Okay, let's put some holes in the middle. What they're going to be, 6 mil. 6 mil. Six mil, right. So, oh, I've put them on top, cut them out, go and paste them in place. We'll just get rid of the holes. Let's give it some thickness, 5 mil. Okay, so we've made ourselves a intermediate wire retainer stroke, yeah. So let's grab hold of it. Let's pretend we're moving it up here. Let's put it over the hole. Put it over there. And we want our first one, let's say, I don't know how far apart, say, let's move it, how far up? I don't know, say 12 inches, a foot. So 30 mil. 30 millimeter. No, 300 millimeter. That's it. So one there. So what we do is we've got to turn it on its side. So let's rotate it on its side. No, we've done that wrong, haven't we? Right, so we need to rotate it. Are we going to do it? No, we can't do it like that. So what we're going to do is undo the move. Undo, set and fit. Right, so we're on there. Right, so what we're going to do is flip it up on its side. It's difficult to do when you haven't got a flat edge. So that's our flat edge, so press the shift, hold it there, reference it. We've got to come off the model a minute and turn it like that, snap it just like that. Now we can bring it somewhere over here. Get over there, you bugger, it won't go. Right, let's bring it over here. Start from there. Is it gonna get me on there? Sort of. No, this perspective's all wrong, isn't it? Hang on. Go on. Right, you have to get the angles right on this one now. So it's not bad, but let's just get around the back of it here. No, I don't want to turn it. I want to move it up to there. Where's the edge? There. Okay. I want to move it over. No, I don't want to move that over. I want to move this over. I grab it from the centre. Is there a centre point on it? Yeah. I want it on there. I won't let us do it. Will that let us do it? Yeah, that'll let us do it. Right, so what have we got now? Let's have a look. Oh, it's still too high. Still a bit high. It doesn't matter. It's midway position. Now we're not over enough. None of this really matters, but we'll have to put it in position. So you want to go 2.5 mil over. Right, so that gives us it's too low. Needs to go up. Why has it gone like that? .5. Right, so is that good? Yeah, that's going through the middle of it. Okay, so we've got it where we want it. We want some more of them. So the idea is, let's move it across, say 300mm. What has happened there? Why has that gone all silly? Has it gone silly? Yeah, it has. Hey? Undo. Right, okay, so what happened there? Right, 300mm. Yeah, we're alright now. Okay, so what we've got ourselves, imagine if we lose that wire comes to there and the other wire ties onto there, so you tie it there to there, and then it gives us a hole. You have another one there, and you feed your wire around through there, and it holds it still. Yeah, and you reproduce these. Reproduce as many as you want of these, and the one at the end, that's wire, that's wire. Does it need to be wire though? Is there any point in having it as wire? No. Just needs to be nylon, doesn't it? It's nylon string. The wire's this way. Right, got you. So it won't be wire, it'll just be a catenary wire to your fence line. And these are standoffs, so you'd have another one of these. Create another one of these. And move it 300mm again. Is that okay, or has it moved off? No, it's gone off. Right, okay. So what you got to do is somehow grab hold of it. So grab it from the back. We've got to keep it on the line there. So we're going to go 300mm. And then we're going to do times, I don't know, say times 5. Now it should have given us 5 in a row. I'm liking this one. I'm liking this one. Mind you, I said the same thing. This looks easier. That's easy to make, and so is this. Right. So you join your wires up. Now we've probably got too many radials now. We probably don't need this many radials. Hex, it's in the word, isn't it? Hex beam. As in hexadecimal, so 6-sided. We've got 12-sided, so right. I've got the right idea, but then we've got to turn it around somewhere else. Right, okay. Right, so yeah, these are our guides. Guides through and around, so 6-sided. Let's start off with a 6-sided. Let's make a 6-sided thing. So we'll have to make this again, I think. 6-sided, so let's go like that. We've got 10 sides, so I'll go 6 sides. Hex, is that going to be enough? So let's go like that. Alright, we're going to do same as that. So will this give us 1, 2, 3, 4, 5, 6? 1, 2, 3, 4, 5, 6. Okay, let's try that. Let's have a quick look at. Oh, I've gone small on the picture for some reason. Right, let's go and have a look at a hex beam. Is it a beam? It is a beam, isn't it? So, hex beam. So we've got some drawings here. So 1, 2, 3, 4, 5, 6 sides. Yeah. Okay. 6 sides. So let's sort out this lot. So we've got to get rid of. Well, let's make it 5mm. Oh, what's happened there? I don't know. Undo that. So we've got. Oh, we're in there in the model already. That's not a good idea, is it? Hang on. Right, we can just start again. Let's start again. So 6-sided, 100mm. Right, so we've got our 6 sides. Let's get our depth. 5mm. Let's just let's come in about 15mm. $15. 15mm. 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 Let's put a hole in it. 3mm, so 6mm diameter. I never thought I'd be making a hex beam. Making a hex beam, eh? Instead of, yeah, it's because it is a fan dipole anyway. It's a fan dipole, but it's just in the shape of a hex beam. It probably fans out better than a. Go on, what's the matter with that? Go on. Let's get rid of these markers. The idea we want to make it was with as few different kinds of components as possible. What's that there? Gonna have to get rid of that line. Right, has that got rid of it? Oh, we've got something else going on here. No, we got rid of it. Let's get rid of that one as well. Alright, let's put them through. Okay, we've got that. Let's make it as a component. Right, and we're gonna, you know what to call it. I'll just call it a hex. Right, so we've got our hex. So what I need to do now is we need to get rid of this one. Can we copy anything off there? Yeah. Now the feed line normally goes up against it, doesn't it? Because it's got to go up different lengths. Well, I don't want to do that. I just want a flat piece. I don't want to make it into a bent, anything bent. So I'm after I want a flat design. So I don't know if it'll work, but we'll give it a go. So it's going to be a flat design. I suppose they bend it just so they can self-contain it, but this is going to be in the garden. The wires go against wherever they can go against the fence in the form of a hex. So you get your angles right straight away. And you can even, put thread it around. Yeah, so we can make it parabolic or something as well. It doesn't have to be a dead circle or rounded or hex shape. Experimental. Right, so let's get rid of the wires. We need wires, but not these directions. Right, so going back to the feed, we could probably just use that now as it is. Has that selected the bottom as well? Yes, it has. So we'll copy that. And we'll paste. Paste it there. I need to grab hold of that. No, let's not do that. Let's undo that. Alright, let's grab this. Just the top bit. Hang on. That, and that. Copy it. Right, so I'm going to open this up. Paste it, paste. Right, so I'm going to paste it there. I'm going to grab this one from the center. And we're going to find the center of this. There, that's it. Can we? Yeah, hollow them out. So we've got the center bit. That's good. Right, so this one can go now. Get rid of that one. This is going to be under the layer of disk now, hex. So we call it hex. Put it under the layer of hex. Okay. Right, we've got our things there, so let's get rid of a few of them. Grab this one. So we need some lines off it now. Lines of flux. We're going to get our lines. So let's just say it's white. The garden's 4 meters by 4 meters. So say 5 by 5. So I'll go 5 meters. 5 meters one way. 5 metres the other. And it's the same all the way around, this one is. So I just want 5 metres all the way around. Alright, a few more left. Oops, come back. 5 metres that way. Last one here. Five metres that way. Okay, so we've got looks quite big, but these are wires to hold it still. So then we want to put this, start again with that, grab it by the corner from the middle and bring it over to the one wire it's parallel with. I can't see it from that angle. So grab it again. Oh, where's it gone? Okay, so I want it from there, and take it down 2.5 mil. Okay, so we've got that on the line. It should be, no, it's not quite right. Oh yeah, because the line's there, that's fine. We can go up, undo, that's it, so leave that where it was fine where it was. Okay, so we've got that there. We need to move it, we don't need one there. So we're going to move it, oh, what's it doing? Needs to go 30 cent, 300 millimeters. So we've got that there. Let's do another. Don't know how many we need, so we're going to do another. It needs to be so 30 millimeters, 300 millimeters, and we're going to times it by 5. Alright, so we've got 5, so we need to do the same. So that'll give us 1 band, 2 band, 3 band, 4 band, 5 band, 6 bands. So we've got 6 bands. I suppose these have to be positioned where the length of each band is to go round, basically. Let's have a quick look at how they do it. Let's try and imagine it. So, what are they doing here? This is the right mess, isn't it? But yeah, it works. So, right. So they've got their radials joined up. So it looks like it's being fed from the middle somehow. Can't quite see the design of it. Hang on, let's find something clearer. Alright, let's have a look at it that way up. So you've got your feed. Oh yeah, you feed one there and one that way, that's right. So you miss a bit, and that's what gives you your direction. Okay, so we can still do that then. Feed, go around. Oh, so do you start from there? You feed, yeah, you start from there, go up. So, yeah, some of this is going to be a feed line then. So you start like that, then you come back in again, do you? Right, I don't know. What's that one? So a reflector wire. Coax feed point. Up like that, round. Driver wire. Tip space. Right, don't know what that is. Let's find something else. Can we see anything from that? So Can't see what's happening with that one. What's this one? Very confusing. Right, so this is, yeah. So it's like a reflector. I don't know. It's confusing to look at, isn't it? Yeah, so here's a different one. Broadband option. Right, so it goes round there, round basically. That's it. And you have an opening space. So it's shorted through. Right, yes, it's shorted through it. It just goes all the way around and shorted through it. So you feed one, you braid one side, you send to the other. Don't know. Right, that's even bigger a mess, isn't it? Right, so there's one. A single or dual, single band, dual band, I don't know. Right, so we're gonna have to try and get this right. See what works. I don't want to do that idea though. Maybe that's the only way they can swire it in, unless that's making it. Don't know. Anyway, we'll start with something. So we've got that. Let's do the same again. Let's copy it. Copy and paste in place. Will it let us do it? Yeah. Let's look at it from above. Let's move it. Get to the center of it. Let's line it up and move it. Move it over here. On there. Let's do the rest. I might as well do the rest. Copy, paste in place, and then again move it. So start from there and we move it to there. So we should have that many. We need to do the rest as well. Copy, paste in place. Move it from there to there. And again, copy, paste in place. Start from there and go to there. So, one more. Copy, paste in place. So from there to there. Right, so we should have one on each side. And all we've got to do now is go right back to the angle. And grab one. Right, we've got to grab it and oops, no, don't do that. So we've got to copy it. Right, and then we're going to go 300mm times 5. Oh, what's it done? So it went wrong. Right. Right, let's try again. Alright, so 300mm and times 5. Yeah, we've got our 5. Rotate it round. We can move them up and down depending on where they got to go. It's just a placeholder really till we get sorted out. Copy it. 300 mil times 5. Right, we got that. Some more. Some more of these. Copy it. $300 mil times 5. Okay. Another 2 to do. Make sure we don't go off straight off. Times 5. Okay. Last one. $300 mil and times 5. Okay, so we've got our spaces. I suppose we could shorten these down if we wanted. I'll leave them like that for now. Right, let's save that. So what I need to do now is stitch these up. I don't know if 300 mil is right or not. Let's see what length that gives us on our last one. From the centre. Get an idea of the scale. Get an idea of the scale. So we say that's our last one. I'll go to the middle there. That's where it'll be. Alright, so let's go up here. Make it easier. Yeah, so it's less. It's about 2 meters. 2 meters, so it's 4 meters wide. 4 meters. I've got 4 meters in the garden, just about. Right, so that's set in the middle of the garden, above head height, like that. And underneath, you'll look at it and you'll see that. If you walk around the garden, you'll see that. But edge on from the fence line, from a distance, you're just going to see hardly anything. Okay, right, sounds good to me. Right, so we've got to try and work out the distance, the length of this stuff. We could do that. So we could do some maths here. Measure the distance. But it doesn't matter because it's the physical stuff you've got to make. You can alter your lengths to suit. So let's do a wire. So we've got to decide where our feed points are coming from. So we've got them two there. We know we've got to start from one X and the other. So what we'll do is we'll come straight from there to there and there to there. That's it. So that would basically be, yeah, so that's basically our feed line. That's an element there. And they'd all be elements all the way up. But then whatever band you're on, it'll use find the right one automatically. Maybe. Yeah, let's try it. Right, so let's connect a wire up from the middle of that to the middle of this one. Okay, that's one. Have we done it right? Yeah, we're coming out of there, we're going that way. Going that way. And we'll stop up there. Right, so let's do another one. Let's do another one. Over to this one. Alright, okay. Let's do another one. Let's get a feel for it. get a feel for what we're looking at here. Okay. Right. So it looks, yeah, it's looking like a satellite dish, apart from it's flat. I wonder why they bow them out like that. Maybe they have to. Right, anyway, I don't know. Experimenting. It's just an experiment. So, I suppose you could flatten it out. I don't know. Let's try it. We'll try one. See what happens. You might be able to tune it in. Might be able to tune it. You never know. Right. So we're almost done one band, and we can try and. What time we got now? 2 hours. So we can try and certainly be far enough apart. Anyway. Alright, so that's the last one. So what we've got some kind of directional. Tell you what we can do. Grab it from the middle. Like that. Come on. Okay, so you could grab it like that, and you could do that. Oh, we can't. We've got to grab the. We've got to group the whole thing, haven't we? Hang on, let's group the whole thing first. Make it into a group, and we can grab this. Right, so it's automatically going to go anyway. Right, so then we can rotate it round like a rotator. Can I just alter the angle a minute? Yeah, I can alter the angle. Go back to the rotating, yeah. Can't really see it though, so we've got that, so we'll rotate it round. Okay, let's get an idea of the length of the wires. So, right, we can get the length of the wire just by measuring one of them. Measuring one of them. Oops, come on. Right, 440. 440, 66. 67. 440, 67. Calculator. Right, so let's just come back into that a bit. Calculator. Right, so 67. Let's say 441 times 5. 1, 2, 3, 4, 5. 2.2 meters. 2.2 meters. So it's joined in the middle. I'll have to work that one out. It's gonna be funny. Yeah. So we've got driven elements. That's a driven element. That's a driven element. The rest aren't. That goes all the way around there. Let's put a few more in. So you could stand underneath. Stand underneath, just above head height. Standing under here, and you could thread thread your cables round once you've got this taut. Once you've got your guide wires taut, now what's going to hold? Yeah, so I suppose the reason they have it cradle, one of the reasons it holds itself together. But the driven element can be finished wherever, then made off with nylon to the fence line. So it's directional as well, so you won't be able to rotate it because you've got these fence. So there's another reason for having it self-contained, so you can rotate it. Yeah, you can't rotate this if it's fastened to the fence. So yeah, that's why they buckle it up and hold it all together. But then you start getting, what about if you don't want it rotate? So there's your driven elements. So a fixed one. Yeah, there's a lot to it. At least when you break it down, you know why they do most things. What about if you don't want a directional one though? Is any way of making hex being omnidirectional? Be like a magnetic loop then, I suppose. But then they're directional as well. I don't know. Anyway, let's do a few more. Put a few more wires in. Just to complete this. Let's just get the idea, see if it can physically be built. I don't want a great big parabolic bowl sticking up. Just want it in line so you can't be seen from, you can only see it from above basically or below, but over a fence all you can see is that. All you can see is that edge on. Right, okay. Let's go on that premise for now. I'm at the minute I'm not bothered about a directional one. I just want to get something long enough for the wavelengths in tune, easy enough to tune. Maybe you could have a flat one, but then you need don't know, we'll just do it stage by stage. Oh, that one doesn't have one. Right, so let's just let's get these wired up and get it wired up. Try the idea out. See if it's feasible. See if it's even feasible. So I'm making a cobweb, nature's own invention. Yeah. Cobweb. Cobweb. Right, so we've got 2 bands nearly done. 2 bands. You have to alter these wherever you need them to tune it. So you could work your length of your wire out before and feed it round. We need some way of adjusting this, you know. So you can adjust these would be fixed, maybe. Or maybe they won't be fixed. Who knows? Got the antenna analyzer anyway, the Nano VNA, so we can have a look at it, see what the hell's going on. Be interesting. And this is not too obtrusive. You've just got to attach it 6 points. It's fixed, non-directional, as in you can't change the direction. It's directional, but you can't change it. Right, let's get the rest done. At the minute I've just spaced these 300mm apart. That's not reference to anything, just so they give them equal distance apart. And we might find there's an optimum distance apart for swapping between bands. So swap between bands. We'll try some of it and analyse it, and we'll see what we need to move. I'll see if what we need to get moved. So these joints will have to be cabled, yeah, looped and then tied with plenty of spare either end, so we can space them out. And also these wires are going to have to be adjustable as well, so that goes through to the element, so we'll have to clip it on or something and then feed it back under itself, just to get the general idea of the wave, you know, just the measurement, get the general gist of it. Maybe. Right. So we'll just get these, see how many bands, see what it looks like. Because these are all the same. So you can mill them out the same. Exactly the same, so there's only two things to mill out here, the middle bit and these plastics here. They're all the same. You could probably 3D print them, don't know if they'd be strong though. I'll laser cut them. I can laser cut this stuff, it'll fit on the laser cutter, whereas that fan dipole thing I made, madness of thing. That thing, it won't fit in the laser, not my laser anyway. It's not that big. So, right, that's that third band done. So, we'll start, say, with 4 meters, 6 meters, 10 meters, 15 meters, 20 meters and 40 meters. Sounds about right. There's a few missing, but yeah, we can sort that out. A few missing, but let's just carry on with what we're doing. Get this filled out, get a feel for it. If it's just a matter of milling that and loads of these out, you can work out how you need. So 1, 2, 3, 4, 5, 6 times 6. 2, 3, 4, 5, 6. 6 sixes, 36 of them, and 1 of them. And the rest is wire and nylon. Wire and nylon. And it could also be disguised as a rotary washing line. Someone says, what's that? It's a rotary washing line. But don't hang your clothes off it. Make a good ground plane, no wet clothes. Wet clothes hanging off it there to pull the whole thing down. The weight. Anyway, I'm sure people have already tried this already. Oh, started funny, I missed that one out. They probably tried this years ago. And they probably worked out it's not a good idea. I'll tell you what would be nice, to be able to automatically adjust these lengths. Put them on some kind of winding mechanism. CNC control adjustment, so you could self-tune. All the bands could self-tune and move around and adjust themselves. I suppose there could be some modelling software, but anyway, I'll just have a play. When I say modelling software, I mean the tuning it up to work out the lengths and the spacing. Right, so we've got another couple to do. It's long-winded, but yeah, get the idea. Right, so I might ask ChatGPT for some info on, see if it can help us out. It's pretty good with doing antenna stuff. It knows a lot about antennas. The theory of it anyway. Right, here we go. Okay. Suppose I could just go ahead and fill that in as well. So I'll have them different colours, maybe. Right, we're getting there. Nearly. So we know what we've got to make. 36 of these and one of them. 36 of them and one of them. Right. Okay. Sure there'd be an easy way of doing this somehow. Oh well. The idea, it's got to be cheap. Cheap and easy. Cheap and easy, very cheap and easy. Cheap and easy. Quick. No poles to put in the floor. Just attach the edges to your fence, whether it be nylon or wire and nylon, bit of both. So it's the milling out of these pieces, or the 3D printing of these pieces. I'll take the time, but or you could just injection mold them, whatever you want to do. That's the open bit, so we just got to do these two. Fill there, get in there. And you could even add more, and if you've got a bigger garden, more bands maybe, or go around. There's got to be more way. There's got to be whether you could double the height, go upwards onto another tier. So basically you could if you start from there, hang on, let's just finish this one off. Finish this and have a look at it. Right, one more. One more. One more. There we go. That's it. Alright. So what we got? We got a cobweb. Alright, it's directional. Cobweb. Right, so okay. So yeah, so if you wanted to start here, if you wanted to do, what happens if you used to copy that and double it and move it up 300 mil, and bring the element up and round the next slot? What would that do? 2 lots of driven elements, 2 lots of, not even sure what it would do. They'll just be in parallel, wouldn't they? Would it add? Yeah, it would add to the length of the cable. So you could make one, then make another one. So is that a group? Right, let's group all this together a minute. That's a group, isn't it? So let's just grab the wires. Oh, that must have been part of the first group, it isn't it? Alright, let's get them out of there first. Get these out of that group. Right, cut. Paste in place. Right, so now we grab the wires. Yeah, because it hasn't grabbed them, that's right, just the wires. So we'll group the wires. Group them. Okay, let's make a new one, call it the web. And put them in the web. Close off the web, yeah. Okay, have I called that anything? A group that I only grouped it, so I need to ungroup that. Explode, edit group. Right, that's it, so we got that. So what have we got? Catenary wires. So that's going to be a catenary wire. Catenary wire, catenary wire. And these are driven elements and catenary wires. Let's put that under catenary wire. Okay. So let's call the other one driven elements. If they are or not, I don't know. Driven elements. Turn them off. And we want the spaces. All the spaces. Yeah. So we call them. What are we going to call them? Spaces? No. Stays. Call them stays. Stays. Alright, so the stays are there. Why does that one look weird? No, it's okay. Right. Web. Hex. Web. And we've got center plate. Element. Disk. I've called it hex. Okay, that's fair enough. Right, put them back on. Put the stays on, and the web, and the elements, no, driven elements, catenary, wires. That's it, isn't it? That's it for now. Alright, so look down at it. What's that over there?
Anybody about this evening?
Yeah, there's someone about, mate. Right. Oh, that's my old stuff, isn't it? That's my old stuff, so I can get rid of that off this one. Let's get rid of that. Right. So, what we got? Got no colours yet, so these need to be coloured. Different bands. Let's colour the bands. Shall we colour the bands? Yeah. No, let's leave the colouring for now. Right. So we've got that. So what's going to hold these is they're tied like that and linked. They're like trains, carriages. They're held together, held together. There you got your feed line, goes to these elements here. So I could put the nuts and bolts in. Alright, so what's one side to the next is 4 meters, nearly 4 meters. So I can get 4 meters in, and then these will be variable. Right, let's see what the length of this outer one is. Roughly 2 meters. So 2 meters times 6, calculator again. So 2000 times 6 is 12. 12 meters. 12 meters. What does that give us? 12 meters. That gives us, what is it? How does it work out? 12 meters of length. I think we better ask ChatGPT something now. Let's see if we can get ChatGPT on. We need to ask ChatGPT a question. Right, there we go. Right, hex multi-band HF web antenna. How are the individual element lengths worked out? See what it's got to say about that. In a hexagonal multi-band HF high-frequency antenna, the lengths of the individual elements are carefully calculated to achieve resonance at multiple amateur radio bands. The style of antenna is commonly known as a hex beam, and it operates on principles similar to a Yagi-Uda antenna, but of a distinctive hexagonal layout, and often without a reflector element for each band. Here's a general overview of how the individual element lengths are determined. Each band that the antenna is designed to operate on has a target resonant frequency. For instance, in amateur radio, a typical multi-band X-beam might target bands like 20 meters, 17, 15, 12 and 10 meters. The resonant frequency are calculated for the center of each of these bands. So calculate the wavelength, the element length, the length of each driven element and director, if used, is typically calculated as a fraction of the wavelength. at the desired resonant frequency. So wavelength characters 300 in meters. F is the frequency in megahertz. The length of each element is usually designed to be close to half of the wavelength, as is typical of a dipole type antenna elements. For example, 14 megahertz 20 meter band, the length of the driven element would be approximately 10.7 meters. Just for hexagonal layout. In a beam, the elements are arranged in a V shape that forms the hexagonal structure. This shape introduces capacitive coupling and mutual inductance between elements, which impacts their effective length. To account for this, each element's length is typically slightly shorter than a standard dipole for the same frequency. Spacing and tuning for the multiband use. Since X-beams are multiband antennas, there are several sets of elements, one for each band, arranged concentrically around the central mast. The spacing and lengths are adjusted so that each set of elements or wire loops resonates on the intended band and with minimal interaction with other bands. This often involves trial and error adjustments and simulation to achieve optimal spacing and to minimize detuning effects from neighboring elements. Practical considerations: tapering and matching. Tapering to reduce weight and wind resistance. Hex beam elements are often tapered, which slightly affects their electrical length. Matching networks. Since multi-band antennas can have varying impedances across band, a matching network or balun is typically used to provide a suitable impedance, typically 50 ohms at the feed point. Example of typical element lengths for a multi-band hex beam. Common X beam setup might include the following approximate lengths for each band's element: 20 meters, 10.5, 17 meters, 8.3. So 10.5 for the 20 meter band. Let's see what we got. So we said we'd got 2 meters, wasn't it? Yeah, 2 meters times, so it's 12 meters. 12 meters, so 10 meters, so yeah, we could do a 20 meter band. Right. I'll see. Is there a way to make it omnidirectional? Yes, although standard experiment is inherently directional, there are methods to achieve an omnidirectional pattern in a multiband HF antenna. There are some ways to make a hex beam or similar hex band HF behave in a more omnidirectional manner. Adding a rotatable reflector or director system. You could add multiple switchable reflector or director elements that can be rotated or electronically selected to change the direction. Okay. By quickly rotating the beam, the directional pattern can approximate an omnidirectional signal over time, which may work for specific applications, but is not a true omni solution. No. Hexagonal vertical dipole. If you're looking for multiband omnidirectional HF using vertical dipoles arranged in X beam can offer a, well, I don't know what that is. Using a non-directional antenna design. For true omnidirectional coverage, using a vertical multiband antenna like a trapped vertical off-center fed vertical dipole fan vertical may be more suitable. No, that's lost me already. Adding phased elements, a phased array of vertical antennas. Right. Employing ground plane, now turnstile antenna, a turnstile antenna crossed dipoles fed 90 degrees out of phase can create a circular or near, right, okay. Multiband halo or loop antenna. Right now. Okay, so go back to the scenario. Oops. Scenario for you. How many band we got? 6 band. Is it 6 band? 1, 2, 3, 4, 5, 6. Okay. So 6 band HF hex beam. Horizontal with catenary wires tied at head height to the fence, angled evenly spaced with plastic spaces to contain the driven elements in a cobweb style. The center plastic plate is 200 millimeters in diameter, shaped as a hex. The wire catenaries and driven feeds and feed points feed points trajectory out from the corners of the hex plate. I have questions. Question 1. Would a hex beam work okay if all if it is a horizontal flat plane Alright, so 2. Question 2. What would the spacing be on the spaces? What would the spacing be on the spaces? Okay. What the hell can it make of that? It crash and die there. Involves a horizontally oriented flat hexagonal HF beam continuing extending out from the centre in a cobweb. The setup is innovative, combining elements of the hex beam cobweb antennas. Let's address each question in detail. Will a hex beam work horizontally on a flat plate? A traditional hex beam is usually mounted on an angle resembling an umbrella. Because of this geometry helps to achieve a directional pattern with some vertical takeoff angles and front to back ratio. However, placing the hex beam in a flat horizontal plane can still work, but will with different characteristics. Radiation pattern. In a horizontal orientation, the hex beam's pattern will be less directional and closer to an omnidirectional pattern in the horizontal plane. You will lose the front to back ratio and gain a broader beam pattern, which might be desirable if you want multi-directional coverage. Ground proximity effects. Since the antenna is near the ground head height, it will be affected by ground reflection. The height above ground influences the angle of the radiation. Typically for effective low angle DX, heights of at least half a wavelength above ground are recommended. For lower frequencies like 20 meter foot height, head height may mean more upward radiation in this or near vertical incidence, skywave propagation, better for local or regional communication than for DX. Performance across bands. Given the design as a hex beam and the reduced height, performance will be vary across the bands. Higher bands, 10 meters, 15, may perform better than lower ones like 20 and 40 in terms of DX capability due to the lower effective height. In summary, yes, it will work in a flat horizontal plane, but with a broader, less directional pattern and reduced front to back ratio. Question 2. What should be the spacing be on the plastic space? For spacing of the plastic space along the continued wire, let's consider a few factors. Element stability and shape. The spaces help keep each band element at the correct length and separation, preventing interaction between them. In traditional hex beams, the spacing of the elements along each catenary is approximately equal, with similar smaller increments for higher bands like 10 meters and larger for lower bands like 20 meters. For a cobweb-like structure, the spacing between bands can be maintained at around 4 to 6 inches, 10 to 15 centimeters for higher bands, 10 meters, 12 meters, and 6 to 8 inches for 15 to 20 for lower bands, 20, 4 to 6 for 10 to 15, right. Preventing coupling between bands to minimize interaction, especially in a horizontal configuration. Space the elements as evenly as possible along the catenary wire. In practice, hex beam spacing generally maintains 5 to 10% of the element's wavelength between the adjacent elements. This equates to approximately 10 to 15 centimeters, 4 to 6 for higher bands, 6 to 8. Right. Recommended placement for stability. Placing a spacer roughly every 20 to 30 centimeters along each catenary wire should provide adequate structural stability and maintain the shape of each driven element. Additional spaces could be added as needed close to the feed point if there are any sag or drooping in the wire. By using these spacings, you'll help ensure that each band resonates independently with minimum interaction, preserving the multi-band functionality of your horizontal flat plane hex beam. Okay, so yeah. Right. So sounds about right. Sounds about right what I've done so far. So making it flat, it will be better omnidirectional, they're saying, and the 300mm spacing's about right. So it's a case of milling that out. That's just suspended in space. So we've got 6 points of reference. So this last one will be right. So let's do the driven elements then. Let's so we'll keep the catenaries in black, and any driven elements will colour it red. Shall we colour it red? Colour it red. Right, metal colours. Let's just colour it red like that. Oh, the whole thing's red. Okay. Right, won't really be red, but let's change it. Right, let's undo that. Undo that. Let's go on here. Let's do a wire from here. So we want to go from there. Oh, I suppose we could just go to the end and see what the length of it is. So that'll go to there. I don't have to join up with that one. So that'll actually be to there. Okay, so it's not quite right. Undo that. What we need to do is measure it from the middle of here. Can we do that? Can't. Gonna have to try and measure it. So we're gonna measure that all the way over to here. All the way to that wire there. It needs to be in the middle. Can't work out how to get that. Oh, it doesn't have to be exactly right, does it? 1860. Let's just call it 1860. 1860. So go to there. 1860. Alright, so go to there. Let's colour it red. Alright, we've got the red element. And we need to work out what the size is from there to there. 3110. 3110. So we need a wire from there. It needs to be in the middle though, doesn't it? Yeah. Let's just go that way. 3110. Oh, that's gone off on a tangent. So from there, needs to go that way. 3110. Is that right? Yeah. Okay, and another one. Let's get rid of that one. So another one. Oh, I forgot what it was now. I forgot what the first size was. Right, let's measure it. Right, what is the size? One 1860. 1860. Let's colour it red. Three 110 was the other one, wasn't it? 3110. From the middle of there. Oh, from the edge of there. It needs to come off on the same angle as that. 3110. Okay. Right, okay, so we've got that. So that's our driven elements. And then we need to take it from there to there. Where's it gone? From there to there. And that needs to be red as well. And we need the one from here to there. And that needs to be red as well. Okay, so we've got driven elements. Go from the feed, and we'll have one for the bands. So 4 meters. Let's just choose some colours. 4 meters, I don't know. Let's go up. Start with orange. Orange. Oh, that's all of them. Why has it done all of them? Oh, it's in there, isn't it? So orange. Then we go to what's next after orange? Green. Is that like horrible? So green. Then we want blue. Is that like a green still? This is really, isn't it? So go like that. That's it. Darker blue. And purple. And what's the next one? Grey. No, we need a different colour now. What colour have we missed? What's it doing? What colour have we missed? Pink. Let's do pink. Yeah, pink. Okay, let's see what we got. Right, we've got a weird one now. It's a weird one. Right, okay. Right, so we've got this. So, yeah, so you see, that's all you see end on. Apart from the coax. 6 carabiners, or eyes, 1, 2, 3, 4, 5, 6. These are catenaries, nylon wires, and these are driven elements and nylon wires. So wire got to be fed to all this. And I'm going to have to do some experiments. So these are going to have to be spread apart. So the element's going to have to be adjustable from the middle. Yeah, so the wire is going to have to be adjustable. How would you make it adjustable? It need to be probably bare wire somehow. Bare wire, so you can get the length right. Once you've got the length right, then you could just cut it to size. Yeah, cut it to size. Alright. Anyway, so that's a different idea. Oh, God, I'm getting tired. Right, that's gonna have to be it, I think. Well, I've got had no drop frames at all. 3 hours, that's plenty long enough. Save that. So I'll carry on tomorrow night. So let's just have a quick overview how we adjusted it out. So we need 36 of these. That'll tie off to there. These driven elements need to go to the feed point. And they get each one of these would tie up to it. So you'd have to wrap So what you could do is put that element through this hole, or feed that in that end, out that end, in that end, or in that end and out there, and this one will go round the cable, come through and round this cable, and that would feed in and out, so it would be wrapped around it and it would be pulling on it that way, so it would actually be touching the cable. So you'd have to make it out of actually there's some aluminium wire you can get. Aluminium wire. Yeah, aluminium wire, maybe. Don't know, we could sort that out. That can be sorted out. Yeah, so we've got a way of adjusting each. Actually, that's an idea. If on these driven elements, that wire could go in there and out the other side, and that could be in there, then you wouldn't need to trim the wire. You could just push it up, push it down. To get this length right, you could just push it up. So it would come in there and go like, and it hold its the tautness would hold itself in position. And then when you put this wire through and then round the cable, that's when you crimp it. So you loop it round and then put a tie on it. That will hold it in place there. Yeah, that's a good idea. Same with all these. Yeah, so and then you'd stop at the last bit. You'd stop the driven element there. Tie it off there, go through there and back through there on itself and back through here and tie that off. Yeah, so that's a way of doing that. That would be catenary there. Or you could take the whole driven element up to the near the end. Don't know what that would do. All the way to the end, apart from the bit of nylon where it attaches. Probably not advisable to do that. So, can the same thing be done with these? No, because these, yeah, they can. Yeah, so there's no need to tie. There's no need to tie that there and cut it and tie another one. You feed it in and out like that. So it comes in that way, along and out, and this one just goes straight through. It doesn't need, because it's nylon, and that can be moved up and down as well. You have to make sure they're spaced evenly. So all these can be pushed up and down. Slid, so cable comes in, that end comes in from this way, goes along there, out through that hole and back out. So you just push this up and down where you want it, where it needs to go, the space wise. So you'd have to start 10 meters. Yeah, start lower down band first, that's right. So you start your lower band, and if you need, try and tune it. If it needs lengthening or raising, this loop that comes round here, through there and back on itself, you'd feed some cable back out that way. If you wanted to make it bigger, feed some cable out and push these up, away like that. Yeah. Or push them in, get that tuned, then go to the next one, next band, do the same again. So you won't have to tie them off, and the fact that they go in and out on angles will hold it still if you keep the wire taut. Yeah. So really, you've just got to fix it to fence. Keep it certain tautness on it. Not too taut as you can't slide them, but slack enough so you can slide them. When you finish, then you could tauten it up some more. I actually got the ideal thing. Actually, I've got some catenary turns. What have I done with them? I bought a load of them. I don't know what I've done with them. What have I done with them? What I've done with them? Put them somewhere. Yeah. I have to get the rest of them. So that's an idea. This is looking easier, this one. So I'd have to make 36 of these. 36. I'd have to make a pigtail with a barrel so I could connect my coax. I'm just wondering if you could use these as tuned radials. So have a vertical mask and this method for tuning your radials. Instead of them being a driven element, use it for your radials. But yeah, no. That's the same as having a wire that way, though, isn't it? So yeah, but you've got tuned aerials then, so you run out of length. Anyway, so I need 6 adjustable tensioners, 6 eyelets. I think I've got that many. To attach it to a fence. 6 lots of nylon to adjust. I know these are nylon. The black ones are nylon. So the black ones are nylon. So the red ones are wire. These are the wire driven elements. They'd have to go to there. Yeah, so you'd have to overlap that there so you could extend it to the right size, and this one. Tie them off with clips or ties to hold them still. Now, how would you build it? So, would you have to build it in situ, or could you? You couldn't really build it. You could assemble it. Yeah, you could assemble each one of these. Put them all together on that wire and have the wires hanging off and just slide them out to where you want them. Could you build it all? Could you feed the wire around? You'll end up with a bit of a mess, so you're better off do it in situ. So the first thing you do is put your catenary wires off it. Now you'd be able to hold it that way and that way and that way and that way, but then this would hang down here, so you do need these wires. So temporary you'd have to put, well, you could put the driven element in. Probably be easier to set it up to start with. I just had a thought. So you could do 6 catenary wires coming out of there, and your element, you could have your catenary wire on it as well because it's made of nylon, and then your element could just feed in along the same length of it. Yeah, you could just feed it along the same length and stop there. That way you could mount it and tension it. Well, that's an idea anyway. That's going to be it for tonight. Oh my god, that's going to be it for tonight. What time is it? 11 o'clock? 3 hours gone. Right, let's save that. That's gonna be it for today. I'm not even gonna bother doing an outro. So thanks for watching. Catch you tomorrow night sometime.